When I start using this logic, it saves me a lot of time, especially when I am showing my design iterations or ideas to my clients within a single script. In this video, I'll be showing you the exact steps that I took to implement that logic in my scripts so that you can take this and use it on your day-to-day practice. You may remember this script from the previous exercise. I'll be using the same thing as my base, and if you remember, we created these attractor points, and these points are basically either going larger or smaller or going into different colors. But in this one, we'll be using this as our base to build some kind of massing. To do so, what I'll be doing, instead of taking all these squares and using them as my guide, I'll be using them as they are to extrude. So I'll extrude these curves, okay, on Z direction. Sometimes my Z button is not working. Z direction with this remapped value. But in this case, I'll be using new remapped values. And what I want to do is, as you see, these distances are going super crazy now. If I connect this, probably I'll start to get some results. However, these results are creating these kind of really large forms or long or tall surfaces. Yet what I want to use these remap numbers as my multiplier to multiply the floor height with the attractor points so that I'll get kind of a slightly better control on the forms that I'm creating in an architectural setting. So instead, between 1 and 0.1, what I can say, I will go with 5 till 15 floors, and within this 5 to 15 floors, I'll be rounding these numbers. When you round these numbers, you won't be able to get 9.5, 9.4. They will be rounded to the nearest value. So when I have this, instead of using them as they are, I'll be multiplying this with the floor height. So I'll grab a panel and I say, let's say the floor height is going to be 5 meters. I'll be using this as 5 meters. When I put this in, you see, I started to get slightly more control in my buildings. Okay. Obviously, if you think you want to go with larger than this, you can say, I want to have 25 floors within my system. But the problem with this system is, if we kind of preview them with a little less opaque colors, if I increase transparency a little, what I started to see is, I started to see my attractor points. Maybe this. I started to see my attractor points, but I also see that they are overlapping with my attractors. And this could be a problem, right? And if you want to use this, you can use this. However, what we can also use, instead of an attractor point here, we can use an attractor curve, and how we can deploy that one. So if I want to use an attractor curve or set of attractor curves, what I will be using first is drawing that curve in my system. Okay, the curve doesn't matter. It can be planar, it may not be planar. It's completely up to you. The next thing that I'll be doing, I'll be getting this curve and putting it as my attractor. And I can basically make a group on this right after I follow the same one. And as you remember, this is the closest point component, which shows the distance between my attractor point and the grid. So instead, I can use pull curve. What this does, not this one, pull point. So what this does, it basically does the same thing. I can take the geometry, I can pull the point, and you see I get the same distances, And when I connect this in, if you press Control and Shift and put those distances back into this one, you see nothing will change. It's the same exact component. However, when you use this one, you can immediately put the curve inside. And when you put the curve inside, you started to see now my massing is kind of tracing the curve that I'm having here, right? So one thing to avoid here, maybe we may say, okay, I want to use this curve as kind of a road. So if you follow this very first tutorial that I have, we were offsetting these curves, right? So I can offset this curve into 2 different directions, okay? And let's say this is going to be like 10 meters, this is going to be 10 meters, okay? And I can do the same thing with the same curve, but this time with -1, okay? And I can put this in. And what I can do is I can basically loft these 2 together, okay? And when you loft these 2 together, what we started to see, maybe I preview this off, maybe we change this color. I don't know, for some reason I don't see anything inside of this curve. Maybe we haven't capped, or that's the reason. Let's see if when we cap this, what's gonna happen. So preview this off. Yeah, it didn't change much, but we still get an idea. Or you know what we can do? We can put wireframes to it, preview this off, and we started to get a slightly better idea, even though we have this guy in. Okay, so this is the curve that, or this is the surface that I have, which will be used as my guide, right? So then the question probably is how I'll take this lofted surface and kind of exclude the ones that are connected with these two, right? Like when probably you don't want to have the overlaps between these curves or this path with the buildings, so to speak. So if I get this building, I'm not gonna get the building. If I put collusion one to many, many to many. So if you put many to many, it will have only one input, but we want to have collusion one to many. So the collider is going to be the object for checking for the collusion. That this is our surfaces. Sorry, this is our grid, and the obstacles are the obstacles that we are having as my curve, right? The road is my obstacle. The problem that we see here, it says rectangle cannot be handled, meaning we just need to put a curve here, and when we connect this as a curve, it will be solved. And what we started to see is getting in true force information. And what we can use this true force is basically this patch, the curves that I have here as my pattern, and I can use this in, and it will give me the ones that are inside or overlapping or intersecting with my path, and the ones that are not intersecting with my path. So you see, what I started to get now is these ones are the intersected ones, so I remove them. These ones are the ones that are not intersected, okay? So what I can do next is, instead of having these all in, I can put this into my equation. And when I've only put this into my equation, and when I only put this into my equation, I started to see that I have the extrusions only for the ones that are inside or that are not touching to what I'm doing or my curve orientation. Obviously, this is one way to approach it, right? And the other thing, so now since I am getting this information, right? But what's going to happen if you want to change this to attractor point again? You would probably want to get different results, right? The attractor points are points. So maybe we create circles around this, okay? And we can say maybe 50 to each. Oh, it's going to be too much. Maybe this, okay? Maybe a little more, all right? So if I connect this in, let's see what's going to happen. So probably now I'm still getting this, not these points on. So these are the distances that I created. This is the multiplication. But now what I need to provide is, as my obstacles, I'll be providing these guys. Okay, and one real quick question here. If I provide circles, if I have something smaller than my circle, they will be inside. So it's going to cut only these guys. However, what I want to do, I want to convert them into a boundary surface so that I can use them as my obstacles, right? Because when you create this as a surface, it will cover all the ground. In other words, when it's a surface, it will touch the curves on a continuous basis. So we take them all out. And when I take a look at this, what I started to get is these guys. And obviously, if you want to have some kind of randomness here, or maybe instead of randomness, you may want to say, okay, I want to have a larger island here. I want to have a smaller island here. So we can go to util, we can go to a gene pool, right click to it, edit it, and let's put this as 5 points, because I'm assuming we have only 5 points. We can make this with 1 decimal with maximum 50, and I can put this in, right click to it, randomize 100%, and when I started to, what I'll see is different sizes, right? Different sizes meaning different variations. In other words, maybe I will just preview these off, okay? And just take this guy. So now what I started to see is I started to get all these small tiny islands that are off when it comes to, or when it hits a point or near to the point. So this is really tiny. So if I increase its size, what I'll started to see is it's going to eat up a lot of surface area so that I create this. Obviously, we can merge these two together, right? So instead of doing this, what I can do, I can connect these two together. For instance, I can pull out this, like pull this geometry in, okay? And then I can put this guy into as my collide, as my obstacle. And I started to get some results. Obviously, they started to have different results now. But what I can do is basically this amount, this amount. Now the problem is we are having 6 trim surface. What I can do is just flatten this all in. Now I will have only, yeah, you see what I'm having now is both these like path and the islands that I want to have. But this is a bit more like fantasy, so you may not want to deploy everything that you see at once. What you can do instead, you can select or you can give this choice to the clients, okay? By the way, if you want to take this script, please go to the link in description and join my school community where you can get this Grasshopper script for free. And what I can do, I can take this out a little more, okay? So I can take this out a little, or I just use the latest island version that I have. Okay. In the meantime, you can create, like, it doesn't have to be a surface, a circle. You can create anything that you wish. All right. But the thing that I'll be doing right now is how we decide or how we can automate this process. For that, we'll be using something called swatch. We'll be using we are going to use something called gate, and the stream filter, not the gate for this. So the gate is basically the information that takes one of these inputs and outputs them only. So for instance, if I put my name here as the stream number 1, my surname here, stream number 2, if I provide, now the gate is 1, therefore it's basically my name. If I want to say, if I put a boolean here, or boolean toggle here, and if I make it false, you see that it's basically stream number 1 because true is number 1. If I make it false, it goes back to my name. However, do we have only these options? No. Maybe we are going to put another thing called you, okay? And we can add to this here, but with only boolean toggles, we won't be able to provide that, right? So how I can do this instead, I can get a value list, and within this value list, right click, edit, and you see one means 1, 2 means 2, or what we can say is name can be 1, surname can be 2, and you can be 3, okay? And we just need to put 3 here, which means 3 means you. So I will put, when I say name, it will get my surname because my surname is basically, if I edit this, my name is going to be 1, right? But my surname is going to be 2. So what I need to do, I need to put this 0, 1, and 2. And when I put this in, you see my name is name, surname is surname, you is you. So what I can do here is basically now use the same logic, stream filter, and taking this stream filter to filter if I want to go with either my attractor points or attractor curve. So what I can do here is I can go with a value list, okay, and right click to it, edit, and say attractor points and or attractor curve here in the second one. And I can say 0 and 1, right? Instead of 1, 2. Obviously you can do that too, but 0 and 1 would make things a lot easier. So I can connect this to here. Yet I am using this equation in 2 places. So what I need to do, I need to create 2 of these, right? Because my first thing that I'm using is my kind of surfaces, right? So attractor points are stream 0, so it's going to be 0. And this one is going to be 1. And I'll be using the same thing, same logic, this time for attractor curves, which are circles, and my attractor points, which are circles, and this guy over here. And this will be my button to place things in. And now instead, putting obstacles, I can put this guy in, okay? And instead of this one, I can put this guy in. Now what I started to see is it's only changing with the attractor curve. Okay, so this is basically your go-to component or your go-to adjustment, all right? So basically what we are doing, we are connecting everything, or using everything from this one single switch. So if I pull a scribble here, I say switch to this, and you can have this guy here. So the good thing about this is when you have this many different options, you can say, oh, this is option 1 and this is option 2. So we can use this with the attractor curve, we can use this with a bunch of attractor points, and you can choose amongst these options. And this will give a lot better idea to your clients. So I have 5 spots open. If you want to go deeper and more serious with Grasshopper, book a call with me with the link in description, and I'll talk to you about what we can do, how I can help you and take you to the next level in your careers. Thank you, and I'll see you in the next one.